Here we are on page 2 of the final semester 1 final review. Let's start at number 20. If triangle WRD is congruent to triangle PLK, then segment WR, the first two letters of the statement, would be congruent to segment PL, first two letters of the statement. If these two triangles are congruent, then angle T would have to be congruent to angle N. Over here we have last letter, third letter, so it would be congruent to QM. Here we go. If we have these two triangles congruent, then XC would be congruent to PW. Over here, if triangle RHK is congruent to WVO, then we would say KRH would be congruent to triangle OWV. Down here we know angle M would be congruent to angle D. For number 26, we're going to find this angle down here. We know since these two are congruent, it's an isosceles triangle, and we know that the base angles theorem says that if those are the same, those are the same. So I'm going to take 34 from 180, and I get 146. These two would have to share that amount, so I get 73 degrees for each of those angles. Over here, it's very similar. We know that this and this are congruent, so these two have to be congruent, so x has to equal 72 degrees. The sum of those two 72-degree angles would be 144, so take that from 180. I get that this angle up here has to be 36. So y equals 36. Down here, we're going to find angles 1 and 2. Angle 2 is going to be supplementary to the exterior angle here because they are a linear pair, so the measure of angle 2 would have to be 75 degrees. And if that's 75, we know the triangle sum theorem says that 180 minus the 68 minus that 75 would give us this measure of angle 1. If I do that, I get 180 minus 143. And I get that the measure is 37 degrees. So measure of angle 1 has to be 37 degrees. For letter B here on 27, we're trying to find this angle out here. We're going to use the fact that these two have to be supplementary, so this would be a 35-degree angle. And I can use those two to get this angle, and this one will be supplementary to it. Or we could use the exterior angle theorem that says that this angle has to be equal to the sum of the two non-adjacent interior angles. Let's use that. 92 plus 35 gives me 127 degrees. So x has to be 127 degrees because exterior angles are equal to the sum of the two non-adjacent interior angles. For number 28, if we know these three angles are these algebraic things, we know that the sum of them would have to equal 180. So 6x plus 3x plus 5x gives me 14x. 11, 2, and negative 1 gives me 12. Solving that, I get 14x equals 168, which gives me an x value of 112. Find the value of x and then the measure of each angle. So we found our x. We have to put 12 back in to get each of the angles. So 6 times 12 plus 11 gives me 72 plus 11 gives me 83 degrees. 3 times 12 is 36. 36 plus 2 is 38 degrees. And 5 times 12 is 60, minus 1 is 59. If we've done this correct, that will add up to 180. And it does. For number 29, we know that DE is 4 and EF is 5. And we want to know the length of AC, and we want to know the length of AB. Well, we know because of the mid-segment theorem that the side that's parallel to this has to be twice as long and parallel to it. So 4 plus 4 would give me 8 for AC. And AB, since this is 5, that would make both of those 5, which makes that 10. For number 30, if angles 3 and 4 are supplementary, and angles 3 and 5 are vertical, and angle 4 is 56 degrees, what's the measure of angle 5? Well, 5 would be a linear pair with angle 4, so I'm going to take 180 minus the 56, and so I get 124 degrees. On the last one on this page, we're asked to find the longest and shortest sides of this figure at the right. To do that, we need to know all the angles. So I'm going to fill in the rest of these. If 125 makes 125, which would leave this one with a 55 degree angle. These two add up to 137. Subtracting from 180, I get 43 for this one. So the longest side of the whole thing is going to be the big triangle opposite the biggest angle. So the largest side of the whole thing is going to be AB. The shortest side of the whole thing is going to be opposite the smallest angle in the small triangle. So the shortest side of the whole thing is going to be side BC.